Hey guys, today we're going to do lesson 6, limits and continuity. And as we get started, we need to know the definition of continuity. There are 3 different characteristics that all together end up making a function continued. Now we can look at a graph and say not continuous, not continuous, not continuous. And we would have done that in an Algebra 1 class or an Algebra 2 class or Math 1, 2, or 3. In calculus, you have to prove. You have to prove why a function is continuous or not continuous. So f of c is defined. 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 So all of those places are defined because they exist. It is not defined at a hole in the graph. Not defined. Not defined. The limit as x approaches c of f of x exists. That means from the left is equal to from the right. And in order for a function to be continuous, f of c must equal the overall limit. So we're going to see how that all comes to play. We're going to start by doing this chart here. So using the graph, find the function value, if it exists, for each given x value. So at x equals 9, the function value is about 3.5. Find the left-hand limit. So from the left, we end up at 3.5. Find the right-hand limit. There is no right-hand limit because that is an endpoint. So the right-hand limit does not exist. Remember, the overall limit or the general limit means the left and right must be the same. So this does not exist. And is f of x continuous at x equals c? It is not continuous at x equals c because at x equals 9, we have a stopping point. Now we're going to focus on x equals 4. X equals 4 has a vertical asymptote. Therefore, there is no functional value from the left approaching 4. We have another stopping point, so it never gets to 4. So this also does not exist. Right-hand limit goes to infinity. Not the same. And we know it is not continuous because it is a vertical asymptote. At x equals 3, functional value is 3.9. From the left, 9. From the right, does not exist. General or overall limit does not exist. It is also not continuous because it stops. X equals 0. Functional value is 6. From the left, 6. From the right, 6. General limit, 6. Yes, it is continuous at that value. If you would like to pause the video and try -3 and -5 on your own, you're welcome to do so. -3, functional value, open circle here, but closed circle here. So your functional value is -6. Left-hand limit is 5. Right-hand limit, 5. General limit, 5. It is not continuous because you have a hole in the graph. Finally, -5. Functional value is going to be your closed circle, -2. Left-hand limit, -2. Right-hand limit, +7. General limit does not exist. No, it is not continuous. Well, limits told us where a function intended to go. Continuity guarantees that the function actually makes it there. So as you look here in this table, there's nothing you need to write down. It's simply some examples of what removable and non-removable discontinuities look like. Removable discontinuities or point discontinuities are holes in the graph. So two-sided limits exist from the left and from the right. The functional value does not exist, but the limit does. Same thing here. Functional value does not exist, but the limit does. There are two types of non-removable. Jump means the function has a disconnect here. So we have a right-hand limit and a left-hand limit. Here's your right, here's your left. They're different. So that means your limit will not exist. Same thing here. Then we have infinite, so at least one of the limits does not exist. In this case, this one is going to negative infinity, this one is going to positive infinity, this one is going to 0, and this one is going to 0. You have another infinite jump discontinuity here, going in this direction, and then in this direction. Example number 2. Find the points or intervals at which the function is continuous and the points at which the function is discontinuous from -5 to 10. Notice that is going to be an open interval from -5 to 10. So it is a good idea when you are dealing with, and I know you're going to be doing this in section 8 of chapter 1, find a colored pencil and color in the interval that you are looking at from -5 to +10. Now in this particular case, it's going to cover your entire graph, but when we go to section 8, you're going to have some graphs that go beyond the intended interval, so you want to make sure that you know what you're looking at. So just a colored pencil, usually something kind of light, will be best, but this kind of lets you know the parts of the graph that you're looking at. All right, so we need to look at some discontinuities. I'm going to start left and work my way right. So -3 is a hole in the graph. It is a removable discontinuity. X equals 3. I know it's not drawn there, but it is implied that you have a vertical asymptote. And a vertical asymptote is a non-removable discontinuity. Then at 5, you have a hole, which is removable. And then at 7, you have a point discontinuity. With a jump, which makes it non-removable. So now we need to write our intervals on which our function is continuous. Remember, our starting point is -5. So we go from -5 to our first discontinuity at -3. And then we go from -3 to +3. Then we go from 3 to 5, from 5 to 7, and from 7 to 10. Now, this next page of your notes just needs a little bit of highlighting. There's not really anything that you need to write down. And I'm not going to read all of this to you, but there are some things that I need for you to make sure that you're paying attention to. This is definition of continuity, just more facts and theorems. We've mainly been focused on we've talked about left continuity, right continuity, continuity at a point where the limit, overall limit, general limit is equal to the functional value. Continuity on an open interval, a function is continuous on an open interval AB if it's continuous at each point in the interval. And on closed, a function is continuous on a closed interval AB if it's continuous on the open interval AB, and the function is continuous from the right at A and continuous from the left at B. Now, this is just some general information about basic functions. Polynomial functions are always continuous. So if there's no denominator, what you have is always continuous. Rational functions are going to be continuous as long as the denominator is not equal to 0. We have an exponential function here. It is continuous on all reals if n is odd, and it is continuous on 0 to infinity if n is even. Sine and cosine are always continuous. B to the x is continuous as long as b is greater than 0 and not equal to 1. Log base b of x is continuous as long as x is greater than 0, b is greater than 0, and b is not equal to 1. And inverse functions are continuous if f of x is continuous on the interval with range r and the inverse exists, and then the inverse is continuous on the domain of r. All of that is much more clear when you are able to see a graph. All right, example number 3. For c equals -3, c equals 3, and c equals 7, find f of c. Find the limit as x approaches c from the left and right and overall, and justify your findings using the 3-part definition of continuity. You're going to want some different colors here. So we're going to begin with c equals -3. So we're going to find f of -3 on our graph. -3 has a closed circle when y is 2. So we have a defined point. So far, so good. Now we're going to find the limit as x approaches -3 from the left of our function. -3 from the left is -1. We're going to find the limit as x approaches -3 from the right of the function. From the right approaching -3 is -1. So our overall limit as x approaches -3 of the function is -1. So to determine whether or not we have a continuous function, we have a functional value and an overall limit, and they are different. So f of x is not continuous at x equals -3 because f of -3 does not equal the limit as x approaches -3 of the function. Three-part definition of continuity. We can do the same thing for c equals 3 and c equals 7. So as you can see, the different colors allows me to save some space. So c equals 3. Start by finding f of 3. So f of 3 does not exist because it is a vertical asymptote. The limit as x approaches 3 from the left of the function is infinity. The limit as x approaches 3 from the right of the function is infinity. F of x is not continuous at x equals 3 because there is no functional value at x equals 3, and the limit does not exist because of unbounded behavior. All right, same thing for c equals 7. F of 7 is 3. The limit as x approaches 7 from the left, and the limit as x approaches 7 from the right. So 7 from the left is 3, and 7 from the right is 6. So f of x is not continuous at x equals 7 because the limit as x approaches 7 from the left does not equal the limit as x approaches 7 from the right. The general limit does not exist. So it can't equal a functional value. Notice how all three parts of the definition of continuity come into play in your answer. Confirming continuity over an interval. You must be able to confirm continuity without a graph or a calculator by using your knowledge of function behavior for parent functions and their transformations. So for example 4, find the values of x where the function is discontinuous. Describe the type, infinite or removable, and justify your answer by using the definition of continuity. So as we look at part A, we should know that x cannot equal 3. X equals 3 is a vertical asymptote. So we know it's not continuous. So what we want to do is look at y. So the limit as x approaches 3 from the left of the function, and the limit as x approaches 3 from the right of the function. Now remember, we need to be able to do that without a calculator. So let's think about that for just a minute. As x approaches 3 from the left and 3 from the right. If I plug in a value to the left of 3, say 2, if I plug in a 2 right there, I get 1 over 2 minus 3. 1 over -1 is -1. So that's going to approach negative infinity. This is kind of like that substitution that we did before. If I plug in a value to the right of 3, say 4, 4 minus 3 is 1, 1 over 1 is 1. So our limits from the right and left don't exist. Our functional value at 3 doesn't exist. So f of x is not continuous at x equals 3 because f of 3 does not equal the limit as x approaches 3 of the function because neither exist. X equals 3 is a vertical asymptote. And while you may be thinking, and your question may be, do I need to include all of that? The more you can include that will justify your answer, the better off you'll be. We're going to start part B by doing our X method, factoring on the top. 12, 7, division by 2, 3 and 4, simplifies to 2. So this is going to equal 2x plus 3x plus 2 over x plus 2. So we know x equals -2 is a whole, which is a removable discontinuity. And I guess we need to go back here. Vertical asymptote was non-removable. So the limit as x approaches -2 from the left, and the limit as x approaches -2 from the right. So these are going to cancel. We just plug our -2 in here, and we get -1 and -1. So the limit exists, but we know that that can happen at a hole in the graph. So we know g of -2 doesn't exist because it is a hole in the graph. So g of x is not continuous at x equals -2 because g of -2 does not equal the limit as x approaches -2 of g of x. Our next topic is on removing discontinuities. Use the definition of continuity to find the value of k. So that's our goal. Find the value of k so that the function is continuous for all real numbers. So it's telling you that it's continuous, but it tells you that the answer to your question is going to be k. So x is less than or equal to 2 is approaching from the left. X is greater than 2 is approaching from the right. The limit as x approaches 2 from the left of g of x means I plug 2 in for x. 2 squared is 4. 4 times k is 4k. The limit as x approaches 2 from the right of g of x is 2k minus 6. So 2k minus 6. In order for a function to be continuous, you must approach the same value from the left and from the right, and they must be equal. So set those two limits equal. 4k equals 2k minus 6, and solve your equation. 2k is -6, so k is -3. So what that implies is that g of x equals -3x squared for x is less than or equal to 2, and -3x minus 6 for x is greater than 2. So your limit as x approaches 2 of g of x, because they're equal, we plug the value in. Negative 3 times 2 squared would be negative 12. So g of x is continuous at x equals 2 if k equals negative 3. G of 2 equals the limit as x approaches 2 of g of x, both of which equal negative 12. Now, what it asks for is to find the value of k. What you need practice on is making sure you understand the definition of continuity as well. And that is why we write all of this extra information in there, because you never know what your question is going to ask you. It may just say, what is k? On a test or on a quiz, what is k? Answer it, you're done. It might say why, it might say prove, it might say justify. So all of this information would be required. So it's good to go ahead and get that practice in there. All right, let's go ahead and look at part B, h of x. We have an absolute value in there. X less than 4, 4 from the left, greater than or equal to 4, 4 from the right. Start with your limit. The limit as x approaches 4 from the left of h of x. From the left indicates negative, so that would be negative 1. And the limit as x approaches 4 from the right of h of x, plugging in that 4 for x, gives us 5k minus 16. Remember, with absolute value, this would equal 1, but if it's a negative direction, it's going to be a negative 1. If it's a positive direction, it's going to be a positive 1. All right. So negative 1 equals 5k minus 16. 15 equals 5k. So k is equal to 3. All right, this implies that h of x is equal to absolute value of x minus 4 over x minus 4 when x is less than 4, and 15 minus 4x when x is greater than or equal to 4. Plugging in a 4 gives us 15 minus 4 times 4, which is negative 1. So your limit as x approaches 4 of your function is negative 1. H of x is continuous at x equals 4. If k equals 3, h of 4 is equal to the limit as x approaches 4 of h of x, which equals negative 1. Again, depending on what your question asks on an assessment, will depend on how much you need. In this particular case, if this were on a test or on a quiz, we could stop here, but we are adding our extras in case it asks you to prove that the function is continuous, or it asks you the value of the limit, or it asks you the value of the functional value. All right, taking a look at example number 5, we have another piecewise function. We're going to need to graph this piecewise function, 1, 2, and 3. We use this graph to help us determine continuity, and it's asking for what values of x, h of x is not continuous. So I'm going to start with the second one. Y is 3 when x is negative 2. That's just a point. So negative 2, 3. That takes care of part 2. Negative 2x minus 5 if x is less than negative 2. So plugging in -2 is going to give me a hole in the graph. So that would be -2 times -2 is 4, and 4 minus 5 is -1. And then I need a slope of -2. So rise 2 and left 1. And that will be part 1. Now, off the top of my head and your head, you probably don't know what this looks like. I actually used my calculator to graph that part and my table to plot it. So x cubed minus 6x plus 3. Graph it. See that it is a cubic function. It's going to be a curve. And I need to know values x greater than -2. So -2, 7 is going to be open. 1, 2, 3, 4, 5, 6, 7. And it's open because it's greater than, not greater than or equal to. And then -2 here. So it's just going to kind of curve here. Looks like 3 is going to be a point on your graph as well. So we're just going to sketch it. And it's going to come below the x-axis and go back up. Again, this is not on graph paper, so it's just a sketch. So according to the graph, the discontinuity is at x equals -2. You have a functional value, but you have two different y values here. So your limit's not going to exist, but your functional value will. So h of -2 is equal to 3. There's your functional value. The limit as x approaches -2 from the left is -1. From the right is +7. Guys, make sure when you create a limit that you don't forget your function. Don't just put the limit equals something. Make sure you don't forget your function. Notice it says justify. So we're going to do a justify and a conclusion here at the bottom. So we're going to justify here. And the justify is going to be our 3 steps. And then we're going to do our conclusion here. So justify, number 1, h of -2 is equal to 3. There's your function value. Number 2, the limit as x approaches -2 of the function does not exist. Limit from the left and from the right are not the same. And 3, the limit as x approaches -2 of the function does not equal the functional value. That is your 3-part definition of continuity. Let's write that down. Notice that's taking place in the justification part. So your conclusion is h of x is not continuous at x equals -2. Again, any questions that you have, make sure you mark them in a different color or make sure you mark them with a sticky note. All right, last couple problems here. Use the 3-part definition of continuity to create a system of equations. We're going back to Math 1. Then find the values of a and b so that f of x is continuous for all real numbers. So you need a system of equations, and then you need to find a and b. All right, so 3-part definition of continuity means you also need a functional value. So let's look at f of -1. When it's equal to -1, the value is 6. So f of negative 1 is equal to 6. Set up your limit as x approaches negative 1 from the left of the function, and the limit as x approaches negative 1 from the right of the function. So from the left, from the right, plugging in negative 1 for x gives you negative 2a minus b. Plugging in negative 1 gives you a plus b. This is where your system comes into play. Remember, your limit from your left and your right must be equal, and they must be equal to your functional value in order for the function to be continuous. So our system. Your first limit equal to your functional value, and your second limit equal to your functional value. Notice your b's are going to cancel here. So negative a is equal to 12, a is equal to negative 12. So your answer is going to be a and b so that the function is continuous, and we're using that three-part definition, and we have found a. So we're going to plug the a value into one of our original equations. It doesn't matter which one to find b. I'm going to use the a plus b equals 6 because that one's the simplest. And a is negative 12. Adding 12 means b is 18. All right, last example, example number 7, parts A, B, C, D, and that should be E. We'll just make that E. I don't know why that's an F. So x approaching, or x less than 3 is approaching from the left, x greater than or equal to 3 is approaching from the right. And we're just quickly going to find these limits. And then we're going to find our functional values. Then we're going to determine the overall limit and whether or not it's continuous. So this is a problem that is very similar to a problem where you're just determining continuity, but it's broken up into parts. So x approaches 3 from the left. 3 from the left of g of x. So 2 times 3 plus 1, 6 plus 1 is 7. 3, approaching 3 from the right of g of x is 3 squared, which is 9. Functional value g of 3 means you're looking for that underlined inequality. Underlined inequality. 3 squared equals 9. Remember, that is your functional value. Overall limit, looking at from the left and from the right, does not exist because the limit as x approaches 3 from the left of the function does not equal the limit as x approaches 3 from the right of the function. So is g of x continuous at x equals 3? Justify? No. Because the limit as x approaches 3 from the left of the function does not equal the limit as x approaches 3 from the right of the function. Therefore, the limit as x approaches 3 of the function can't equal the functional value. So g of x is not continuous at x equals 3. In summary, if a function is continuous at a point, then the function value and the limit value are the same at that point. And if you think about the problems that we've done today and the exercises we've done today, that should make sense to you. Hope you guys have a great day, and I will see you soon. Let me know if you have any questions.